Okay, so continuing on, you notice that the problems have been getting a bit more complicated. In particular, problem 9 took quite a bit of time to solve. But we are going to just keep going, keep chugging along. So 10. G is equal to ax squared plus 24. Okay, so this is a simple quadratic equation. Noticeably, it's not a linear equation, so we're not dealing with linear equations anymore. For the function g defined above, a is a constant. Okay, that's kind of obvious. And g of 4 is equal to 8. What is the value of g of negative 4? Well, it's also going to be 8. Okay, but you're probably wondering how I did that so quickly. Let me do this the more algebraic way. We know that g of 4 is 8, so let's actually use that information. So g of 4 is equal to, well, if I plug this into here, that would be a times 4 squared plus 24. So I plugged in 4 for x, right, because that's exactly what we do. And this is equal to 8, because g of 4 is equal to 8. So this is the equation that I can solve. And we can solve this for a. So let's do that. 4 squared, well, that's 16. 8 times 16 plus 24 is equal to 8. I can subtract 24 from both sides. Minus 24. So I get a times 16 is equal to 8 minus 24 is negative 16. And then divide both sides by 16. And I will get a is equal to negative 1. So I found what a is. And I'm going to need some more paper. So I found what a is, and so we can actually rewrite, bring this down, so we can rewrite g of x to be negative 1 times x squared plus 24. Now that we've solved for a, we can know exactly what this expression is. So now we need to find the value of g of minus 4. So I'm just going to plug in minus 4 for the x value, negative 1 times minus 4 squared plus 24. Okay, minus 4 squared, so the minus is going to go away because any negative number squared becomes positive. So negative 4 times negative 4 is 16. So I'm going to get minus 1 times 16 plus 24. Minus 1 times 16 is minus 16 plus 24. And 24 minus 16 is just 8. So, and that's the answer choice, 8. So you might be wondering how I did this in my head initially the first time, so let me show you the way that I was thinking about it. I guess I should state now I'm actually a very visual learner, so I play around with these equations and I kind of see their functions more. So when I look at this, what I notice is this is a quadratic, and the fundamental quadratic looks something like this, if I could draw. I did not go to art school. And I noticed that we're multiplying a quadratic by a, and if you multiply that by a, that's just going to shrink or expand it. But that's not going to change that it's an even function. So there's a mirror symmetry to this. Anything on this side is the same as anything on this side. And if we just shrink or contract it, or expand or contract it, it's going to still have that symmetry. And then if we add 24 to it, all that's going to do is that's going to push us up. So it's going to look something more like this now, where this is 24. Dupe. But you notice again, it still maintains its even symmetry. So knowing that, they tell me that g of 4, which is over here, and I'm going to put negative 4 in as well. So g of 4 is 8. So this value is 8, which means that g of negative 4 must also be 8 because of the symmetry. So it's the same value. So that's how I got a. So that's another way of thinking about it for the more visually minded people. Okay, and then let's go to problem 11. Okay, so upon first inspection, this looks like a system of linear equations. In the equations above, B and C represent the price per pound of beef and chicken, respectively. Okay, let's go over this now. I find that a lot of students don't know what respectively means, and it's very important in math problems. So all this means is that we listed B and C in an order, so we said B, then C, and then we listed the price per pound of beef and chicken. So then we listed beef and chicken. Respectively just means that the first thing from the list corresponds to the first thing from the second list, and then the second thing from the first list corresponds to the second thing from the second list. So this just means that B represents beef, C represents chicken. And X weeks after July 1st, so X is really just a time during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So here's the actual question part. Price per pound of beef when it was equal to the price per pound of chicken. So B is the price per pound of beef, and we're saying that it was equal to the price per pound of chicken. So C. So B is equal to C. That's what they said. And I notice here, B is equal to this thing, and C is equal to this thing. But B is also equal to C. So we can start substituting like mad at this point. Let me just write the first equation here. 2.35 plus 0.25x. So B is equal to this, but B is equal to C, so this thing is also equal to C. But C is also equal to this thing, so this is 2.35 plus 0.25x is equal to C, which is equal to this, so I'm just going to plug that in, 1.75 plus 0.4x. And now I have this expression. And this is actually something that I can solve. I couldn't really solve anything before because I didn't really know what B was, I didn't know what C was, but now I have an equation that has one variable in it, just x. So you can see that here. So we're going to just solve for x. And I'm going to put like terms together, so I'm going to subtract 1.75 from both sides. Minus 1.75. So 2.35 minus 1.75 is 0.6 plus 0.25x is equal to, and then this is just going to cancel, so that's equal to 0.4x. And now I want to subtract 0.25x from the left-hand side and from the right-hand side. And the 0.6 is going to stay there, but the x's are going to go away. And that's going to be 0.4 minus 0.25 is 0.15. And so you might not know this off the top of your head, but if you imagine this to be 60 and this to be 15, then x is 4. And then you just divide both sides by 100, so that doesn't really change the equation though, so x becomes 4. And so x is 4. I look at my answer choices. I notice that none of them are 4, so let me reread the question. What was the price per pound of beef when it was equal to the price per pound of chicken? Okay, so they're really asking us what's the price per pound of beef or chicken since they're equal. So we have to find what B is. We found what X is, so I'm going to put that in the box because it's royalty. We need to separate it from all the rest of the bad numbers. X is in its own box, and we need to find B. We have an expression for B in terms of X, so let's just plug in our X value. 0.25 times X is 4, so this becomes, okay, and then looking at this, I get 0.25 times 4. We're just thinking of this more as like a quarter. 4 quarters makes $1, so this is 1. Or you can just multiply it out on the side of the page if you really needed to. But 2.35 plus 1 is 3.35, so $3.35, and that is one of our answer choices, so it's D. Okay. And then I'm going to do one last problem in this video, so 12. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? Okay, so I think they told me all the information I need for a line. This is a line, so a line is a linear equation, obviously. So we have y is equal to mx plus b. And they told us that it passes through the origin. So if it passes through the origin, then the y-intercept is 0. Because it would look something like, if I can make it intersect properly, it would look something like this. So the y-intercept becomes 0, because that's where the origin is. So b is 0. And then they actually give me the slope. They tell me that it's 1/7. So my equation is y is equal to 1/7 x. So a pretty simple equation. But then the actual question, which of the following points lies on the line? Well, there's no way to do this other than just plugging in all of the points individually. So if I plugged in 0 for x, then this side becomes 0, and y is equal to 0, would be equal to 0, but this is saying that y is equal to 7. You know what, let me just plug both in. So this is saying x is 0 and y is 7. So let's see what happens when I do that. So 7 for y is equal to 1/7 times 0, but that's equal to 0. So now this says that 7 is equal to 0. That's obviously not true, which means that this cannot lie on the line. B says that 7 is equal to 1/7 times 1, so the x is 1 and the y is 7 in this case. But this is just 1/7, so 7 is not equal to 1/7. So that's also not true, so that means it doesn't lie on the line either. The way that that might have been confusing. It lies on the line if it satisfies the equation. So this line can be thought of as a constraint on your x and y's. So this is really saying that y has to be 1/7 of the value of x. So if you thought of it that way, that's how I'm doing these that's how I'm doing these tests, really. So then let's just plug in the third one. So 7 is equal to 1/7 times 7. Oops. So 1/7 times 7 is 1. 7 is not equal to 1, which means it does not satisfy the condition of the line, which means it does not lie on the line. At this point the answer is D, but let's just plug it in to make sure. So this is saying that the y value is 2, and then 1/7 times the x value, which in this case is 14. So 14 divided by 7 is 2. 2 is equal to 2, which means that this does lie on the line, so now I'm happy. That is the correct answer. So we managed to solve it, but I kind of wanted to show a visual way of doing this that might be a bit faster for those that are more visually minded. We have, so here's just an xy plane, and then here is a reference line. It's the value y is equal to x, and we know that our line is y is equal to 1/7 x, which means that it's going to be like down here. The slope is far less. So this would be y is equal to 1/7 x. Just knowing that, you can plot these points and see immediately that most of them don't make any sense. So A says 0, 7, so that's like up here. Well, that's above this reference line. So it's not anywhere close to our line. And then we have 1, 7, which would be like here, which is above our reference line, so it's not satisfying our slope for sure. And then we have 7, 7, which would be like out here or so, which would actually lie on this line, but that's different from our line. And then the only point that's actually below our reference line is 14, 2, which is like out here or so. So it's actually the closest to our line. So you can think of it that way, and then you can actually cross off the first three options pretty easily. So we're going to continue along, starting with problem 13 in the next video.